Okay, jumping back into part 3 of the extra math 2. I'll just show it here real quick. I got to get this done real fast, so we'll probably only finish this page. So again, the HubSpot tests, extra math, this is going to be mostly more for advanced students, or if you're looking to learn some extra tricks. So let's fly through this one. So I see this table problem, and I'm always going to highlight stuff. So we have 300 students from each of the two schools. So I think that's important to remember, at least for me. So we have 300 from this school and 300 from this school, and asked each student how many siblings they have. So it's pretty easy, right? 0 through 4, and these two columns again should add up to 300 each. This looks pretty important too. So there's a total of 2,400 at this school, and a total, let me change the color there too, and a total of 3,300 at this school. So this could turn into maybe a sample size population type of problem too. But let's focus on 19 first. So 19 says the median number of siblings for all the students surveyed. So just specifically those 600 students. So remember, for median, I always want to try to think of like, what number am I going to hit my median in order? So if I have 600, let's kind of break this down. If I split this in 2, so it is an even number, so I'm actually going to have 2 in the middle. So if I have 1 and 1, these are my middle two numbers, what's left? And it should be 299 and 299. This should add up to 600 total, right? So if I think, at what point am I going to hit my median? It should be my 300th and 301st number, right? So I look up at my table and I go, okay, 260 so far. You always want to go cumulative with our medians. 260 so far are going to be zeros. So 260 zeros. And then the next 42 numbers, way more than that actually, the next 190 numbers are going to be ones. So that goes way past my 301st and 300th number. So I know my median here is going to be a 1. So that's an excellent way to always find your median. It's super easy to do it that way. So not bad there, right? 20 I think is going to get a little bit more interesting. I'll jump back up to the table if we need it. So this one's asking, based on the survey data, which of the following most accurately compares the expected total number of students with 4 siblings at the two schools? So let's be really careful here, right? The trap answer might be, okay, I look at my table. They said 4 siblings, right? So it would be 10 out of 300 and 10 out of 300. So it looks like it would be kind of equal. Out of the 300 students from each school, I'm going to get 10 out of 300. So let's start with writing that down, right? So this one will be the smaller school. This little column here will be the bigger school. So 10 out of 300. Let's shift this over. 10 out of 300 here, and 10 out of 300 here. So is it just going to be answer A? The total number of students with 4 siblings is expected to be equal at the two schools. Sample versus population. In the sample size, it happened to be equal. Remember, the smaller school is going to have 2,400 students, and the bigger school is going to have 3,300 students. So what the sample gives us, it's pretty cool, is it gives us our percentage, our expected percentage of the students at that school. So if I do that, if I do 10 divided by 300, that's going to give me my percentage. And I take 10 divided by 300 and I multiply it by 2,400. So this school is expected to have 80 students that have 4 siblings. And I do the same thing on the other side. 10 divided by 300. 10 divided by 300 times 3,300. And I get 110. So it looks like the bigger school is going to have 30 more students. That makes sense. If they have the same percentage, but one school has more students, they're going to have more people with 4 siblings. So I look at my answers. Lincoln, I think Lincoln's the smaller one. I think Washington's the bigger one, but let's make sure it's C here. Washington's the bigger school? Yeah. So C for number 20. Very cool problem. I think that's excellent. It's awesome to practice our median. It's awesome to practice our population versus sample size. Let's continue though. I got to finish this page real fast. Number 21 here. Number 21 is an interesting one. They can get pretty fancy with the context. So let's look at it. Let's dive into it. A project manager estimates that a project will take X hours to complete where X is greater than 100. So let's just say 101. okay? So with these more convoluted problems, don't try to actually feel out the logic, plug in easy numbers. So x is 101. The goal is for the estimate. So that's how, I think that's how long it takes. Let's look at, or no, that's the estimate. Estimate, sorry. So the x is the estimate. That means they're going to give us something else, I think. The goal is for the estimate to be within 10 hours. So just, ahead of time, I glanced down below. They are using less than or greater than. So no less than or equal to. So instead of using 10, I want to use 9 here. Does that make sense? So if it was less than or equal to signs down here, I would be completely fine with using 10. But since they're less than signs or greater than signs, I'm going to stick to just 9. So if 101 is my estimate, I'm allowed to go up to 110. And then I can go down to, what is that, -1, -8, 92. So these would be the two numbers I'm allowed. So always think of like plus or minus 10 hours, but I'm doing 9 because I have to be greater than or less than, not equal to. So let's go through the rest of it. If they meet the goal and it takes y hours, so remember that y is going to be our actual number. So this is y and this is y, and this guy right here is going to be my x. So let's see what we got down below now. Which of the following inequalities represents a relationship? Well, it's easy for us now because we have numbers for x and y. So if x is 101, y can be anything. This is never going to be less than 10. B, y could be 92. That's definitely not going to be greater than 101 plus 10. So you can see how easy this is when we kind of plug in numbers for ourselves. Y could be 92, less than, okay, so I could make y 110. 110 is never going to be less than 101 minus 10. And then here is like the golden inequality. We have our y and x interacting in the middle. I could make y 110 minus 101, going to be less than 10. I could make y 92 minus 101 greater than -10. So no matter what extreme I take, D is going to work. Excellent problem to practice. But let's continue. We got to finish this page. Okay, maybe not. This is another really interesting one. With these types of problems, you always want to think of like your approach to attack the equation. So what variable do we want to attack here for 23? I see that I is related, so this I is related to power and radius. So 4 pi is just going to be a constant. I'm not as worried about that. For the same signal, so I'm assuming this is going to be our signal, emitted by a radio antenna, observer A, so let's say A is going to be over here, and observer B, let's say B is over here. The intensity is to be 16 times the intensity measured by observer B. So we just give them easy numbers. This guy gets 16, and this one gets a 1. 16 times stronger, right? And they ask us the distance of observer A from the radio antenna. So the distance, what letter is that going to be up above? At a distance R. Okay, so R is going to be the determining factor here. It sounds like they're laying out for us. The distance of observer A is what fraction of the distance of observer B. So why are they saying that? Like, how are we going to get a 16 times difference using distance? So if I gave radius 1 for the left and radius 1 for the right, I would get 1 and 1. If I use 2, I would get divided by 4, and I would get divided by 4. So I have to try to come up with maybe like a difference. So what if we do 2 and 1, right? So if I do 2 for the first one, I would get divided by 4. And if I did 1 for B over here, I would get divided by 1. So I want the left one to be greater than, right? So what fraction could I use for the left one to make it greater than the right one, right? And I looked down at my answers. I was trying to kind of solve it using, maybe like more conceptually. But if I just glance at my answers, if I do 1/4 as my fraction over here, and then if it was a 1/4 fraction, that means this would be 1. So this would end up being 1 divided by 1. And this one over here, I would end up doing 1 divided by 1/4 squared. 1/4 squared, so I end up 1 over 1 divided by 16. And remember, when you divide by fractions, you multiply by the reciprocal. So this would actually turn into 1 times 16 over 1. So it looks like our fraction's just going to be A here. The thing we want to really focus on is just our context, right? We have A, we have B. I know A wants to be 16 times bigger, and I know I'm dealing with my radius. I remember to square my radius, and I know I'm dividing by fractions, so it's actually going to end up multiplying by that number. So really, not too bad there. Okay, we're getting really close here. Number 25, this is probably the finale because I do have to go. But let's finish this one off real quick. So we have a graph here of a linear function that has intercepts at, and I just draw this because I'm talking about some intercepts. And it looks like A0, so that's going to be my x and my y. So A and my x is 0 and my y, so this guy's going to be A. And then I get 0b, so this is going to be my b up here. If A plus b is equal to 0, so I already kind of drew it wrong because this would be positive plus positive. So let's redraw our b. We'll keep A. You can do either one. You can keep b, redraw A, etc. So we're going to redraw our b, and if A is positive here, so this is positive, that's not the best color. B would have to be negative to kind of cancel it out. So I would put B down here. And then if I made A negative, let's do a different color. If I made A negative, B would have to be positive. So this would be A and this would be B, and both of our lines are going to have a positive slope. So again, really not too bad. Excellent problems, really good worksheet. You have to stay tuned for the next page because those are going to be some of the better problems that you see on these practice tests.